A tutorial for the 7332 Rev 0 stock for the 3+1 wrap project. Okay, the first thing we're going to do is model this. We have a tight tolerance bore. This is a typical cylindrical part for fourth axis. Oftentimes they go to a lathe first and then are machined. But in this case, we've got a tight tolerance bar and a tight tolerance, and that'll help us index it when we put it in the machine. And then our part will be machined out of this. Okay, so let's go ahead and get going. We're going to do this as a revolve. We're going to leave the chamfer features off, but we're basically going to do this layer cake shape and revolve most of this. I like to put the chamfers on, if I can, last as a feature so that they can be suppressed if they're an issue with programming, when you can do countersinks with the whole features. Here we go. So we're going to go to Fusion and we're going to create our new file. I would start off by saving it. It starts the autosave recovery. If you don't do that, it doesn't initiate it until the very first time you save. So you lose everything you did before that. Okay, so it's 7332 Rev 0, your initial and last name. Okay, we're going to make a sketch. We're going to do that on the front view. We're going to start sketching. It's kind of semantics on where origin is for this. But I'm going to draw a line to the left, up, make our first layer, second layer, and then our third layer. Alright, so you should have some constraints that already go in automatically. Our overall length of the part is, the finished part is 3 inches. Set this dimension to 3 inches, the video is incorrect. And if we look at our drawing, the length of this leg on the right, this very first one, is 490 thousandths. Our next one is 1 inch 10 thousandths from that edge. So, and then our last leg should be taken care of by the overall length. Now we need to do radiuses. So we have our first one is a 146 to 148. So we're going to do that right at the middle of the tolerance at 149.7. So 1.497 divided by 2 gives us the radius. Alright, we're going to go back to the next one, and our next diameter is 2 inches, 494. And we're going to divide that by 2 as well to get a radius. And then our last diameter is 3 inches, so it's 1.5 for the radius. And that should give us fully constrained sketch. Okay, and this overall length is 3 inches. Hit finish. We're going to go to revolve. We're going to select the straight line as our revolve axis, and we should have the main feature of our part made now. Okay, next what we're going to do is we're going to put the next primary feature in, which is the hole in the center. We want that all concentric. So we're going to create the hole, and we're going to do a plain hole type, no tap, it's clearance all the way through. We don't care about the drill points because we're going to go all the way through. So we're going to select all. We are going to pick a countersink hole type so that we can put at least the countersink on the top of the hole there. This software doesn't have the capability to do it on both ends, but some software does. Okay, we're going to select our plane and we're going to move the hole to snap to the center. We need to look at our parameters. So our hole diameter is a 1/2 inch. Okay, and our chamfer angle is 90, or our countersink angle is 90, and our countersink diameter is 560 thousandths. Gotta remember that decimal. We're gonna hit OK. So now we have the hole feature going through the center. Now let's prepare a sketch for the dowel pin hole. So we have a location dowel pin hole that's intended to clock this, so that you can take it on and off the machine and have it clocked in the correct orientation. Also keeps it from spinning because we're going to be bolting this with a drawbar going all the way through the part. Okay, so we need to create a sketch to put this 1 inch from the center. You could use other methods, but I prefer to put a sketch. That way we have something that's hard there that we can change. So we're going to go sketch, and we're going to do a line. We're going to go from origin, we're going to go straight up. We're going to right click on that line, we're going to make that, you're going to left click on the line and then right click on it, make it construction, and that should be 1 inch long. And there we go. We just finished that sketch. Now we're going to go to Hole Wizard and we're going to create the hole that's going to go there. So we're going to do the same thing, countersink, plain hole. This one is going to be blind, so we do want a drill point. And then we're going to do our selection, which is on that point we just created. Now the default size is the last hole size we made. So what we're making is it's a 251 to 253 hole. 251 to 253, so we're going to model that at 252. So we're going to model that at 0.252, and then our countersink width was 0.31. Remember, if I put it in the wrong hole, and we're not going all the way through. Our distance, according to our drawing, is 260 thousandths deep, and there's our hole feature. We'll hit OK. Okay, now all we have is chamfers. So we have one here, and to put the countersink on the opposite side, we're going to use the chamfer tool. So let's go to modify, we're going to go to chamfer, and our first selection is going to be this outside chamfer here, and they're all different sizes on this thing. So we have a 50 thousandths chamfer there. And then we're going to add another selection, which will be this edge, which is just a general edge break of 10 thousandths. Okay, and then we go to the other side, and we need to do a little math to figure out what this one is. We have to convert the countersink diameter to a chamfer dimension. So it is 560 thousandths, and the hole is 500. So if we get our handy dandy calculator out, you have a 0.56 hole, or chamfer diameter, on a hole that is ½ inch. So we're going to subtract a ½ inch from that number. That gives us the difference between the diameters, but the chamfer would be in a radius. So we're going to divide that by 2, and it's a 30 thousandths chamfer is the conversion. Okay, so we're going to go back to Fusion, and we're going to select a new selection set. We're going to pick the opposite end of the hole, and 0.03 is our number. Okay, and we're done with that. Okay, we've now successfully modeled the part. Make sure you're saving a lot. Okay, so we're going to make stock on this. We're going to make stock to go around. It's easier to register things with fixtures if you model the stock. So what we're going to do is we're going to do a sketch, and we're going to do a sketch on the back side of the part. And there's a couple ways you can approach it. What I'm going to do is I'm going to create a projection, and we're going to select the outside diameter of our part, and we're going to hit OK. And so it shows up as purple, but this is it'll tie it to the size of this, and we're making it out of 3-inch bar stock. So if we change the bar stock size, it'll automatically update this model. I'm going to hit Finish Sketch. We're going to do an extrusion, and we're going to select our outside profile, but we also have to select edge where the hole is. So we want it solid as if the stock was being created. We're going to go to 2 sides. The first side is 0.06 and the second side is going to be 3.06. So we're taking 60 thousandths off both sides. Yeah, it looks like I got those boxes backwards, so bear with me here. And then we don't want it to be a cut, we want it to be a new body. Okay, we can see the new body's enveloping the other model. We hit OK. And the second body shows up here. We call this stock. Okay, and we're going to go right click on stock, and we're going to go down to opacity control, and we're going to make it 50% so we can see our part inside the stock. Okay, we have our part modeled, we have the stock around it modeled. Now we need to bring in our vices. And we're also going to use a device called a V-block. So pull in a vise from the assignment, and we're going to pick 1 1/8" tall parallels. And we're going to rotate the vise in the orientation for the first operation. So we need to rotate this 90 one way and 90 the other way. And let's move this out of the way because the first operation is going to be just milling this face here. Now I found assembling these things with cylinders is a little tricky with using square fixturing. So we're going to hit OK. For our first entity we brought in, we need to unground it from parent so that it can be so our joints can be successful. And we're going to expand our vise here, and we're going to do something a little unorthodox, but I want to expand the rear jaw and the front jaw and look at all the bodies. So make sure the bodies are open, and we're going to hide the jaw, the fixed jaw, just temporarily on this, and we're going to go to joints, and this will allow us to pick on the back plane of the parallel, and then we can pick on the corresponding location where it would hit tangency on our cylinder. Okay, and that way it'll align it. And again, you have to have snap points enabled for this, okay, to have those icons, snap points, show up. And we're going to make the hard jaw visible again. We're going to put a V-block in here that's going to go where this parallel is. You can put 2 parallels under this when you machine it, but it's not going to be there. So what we're going to do is hide the parallel on the rear jaw, or the movable jaw. Okay, now we can collapse all this stuff up, and we can go to our library and pull in the V-block that's part of the assignment. And pull that over. We go 90 and 90. That puts it in the orientation the V is going to grip onto the cylinder. We hit OK. Now we're going to go to joints. We're going to pick the center of the rear jaw and center corresponding spot on our V-block, and we're going to hit OK, and that should assemble it where it needs to go. Now, so that the V touches the cylinder and this looks convincing, we're going to go to tangent relationship, and we're going to make a relationship between one of the flat faces and the cylinder of our part, and that should emulate our first operation. Now we're going to go to the opposite side and look at flipping the part like this. So let's hide our vise. And we're going to bring in a second instance of that vise with the same height parallels. Inch and an eighth. Hit OK. I can't see our part. Let's move it. We got to rotate 90 like this. Like so. Move it into position. Hit OK. We're going to expand that vise, front and rear jaw, bodies for both. We're going to hide the parallel in the back, and we're going to hide the hard jaw temporarily in the front. We need to make the joint on this between the finished part edge that's been milled off on the face and the parallel. So we're going to go to make things easier, we're going to go to the bodies and we're going to hide our stock model, and we're going to assemble this with a joint from the back of the parallel to this corresponding edge on the model. And the reason we're doing that is this bottom edge here has been machined to finished size. So if you pick the stock, your setup's going to be off by how much you removed from the first operation. Alright, we're going to hit OK. Now we need to go in and bring in a second instance of the V block. Need to put it in position. Two 90-degree flips. We're going to assemble, we're going to joint, center back wall, center of the V block, hit OK. That puts it in place. Now we need to go to assemble and put our tangent relationship between the V block and our part. We're going to hit OK. And we can go back and make the stock visible again. You are going to need it for both operations. Okay, let's hide the bodies, hide all this stuff. We don't need to see any of this anymore. Okay, and now we're ready to go into the manufacture mode.